stoichiometry. This is a sample of a stoichiometric problem. So we have here the reaction of the iron and oxygen. This is actually the rusting of iron. Now, before you're going to solve any stoichiometric problem, so if it will be based on the balance equation, so see to it that the equation or the reaction is balanced. So the equation that we have is not yet balanced, so we have to balance it first. So this must be 2 moles of ferric oxide, and oxygen is 6, so this must be 3, and iron is 4. Okay? So the equation now is balanced. So the discussion before was we had a stoichiometric relationship based on the formula of the compound. In this time, if there is already a chemical reaction, we can also formulate a stoichiometric equation or stoichiometric relationship based on the balance equation. So if you are going to have a stoichiometric relationship based on the balance equation, this means that you have 4 moles of iron. That would be equivalent to, or it needs 3 moles of oxygen, so that it will produce 2 moles of ferric oxide. So this is actually one of the stoichiometric relationship that is based on the balance equation. So we have here 2 problems, but before we are going to start, for stoichiometric problem, this is the basic steps on how to do it. So first is, if the given is in grams of the substance, given substance, then first you're going to convert it to moles. So you have here, if it will start with the grams of the given substance, you're going to convert it to moles. And for a while class, and it will be converted to moles of the given substance using the molar mass. So once you have now the moles of the given substance, you're going to convert it or change it to moles of the desired. Take note, desired substance. So on how to do it, you're going to use the balance equation. Use the stoichiometric, this one. Use the stoichiometric relationship. So once you have the moles of the desired, desired substance, then you can convert it to grams of the desired substance. Again, using the molar mass. So for example, if the final requirement is the density or the volume, then you can make use of the formula of the density. If the final requirement is up to grams only, so you will stop up to here, or if the required is moles of the desired substance, so you can stop up to here. Okay, so for example, problem number 1. So how many grams of iron rust for every 20 moles of oxygen that is combined with it? So you start with what is being asked. So that is for letter A. What is the requirement? Grams of iron. So you can have grams of iron will be equal to, and start from the given. The given is 20 moles of oxygen. Oxygen, take note, that is O2. So if you are going to base it in the steps, so you have already started in this step. So this 1 grams, so no need for the conversion into grams, so you just follow the steps. So it started here, moles of the given substance. So the given substance is oxygen. So you are going to change it to moles of the desired substance. What is the desired substance? That is iron. Okay, so the desired substance is iron, and the desired unit is in grams. So since the given is already in moles, so you can change this one to moles of the desired substance. So the desired substance is iron. So to convert from one substance to another, you're going to make use of the balance equation. So the ratio or the relationship between iron and oxygen is 4:3. So 4 moles of iron needs 3 moles of oxygen. So you can write it here to convert the moles oxygen to moles iron. So you can have 4 moles of iron. This is based on the balance equation. For every 3 moles of oxygen. So you can cancel out the moles of oxygen, moles oxygen. So the remaining unit now is moles iron. But the requirement is grams iron. Okay, so to change from moles to grams, you are going to use the molar mass. So for every 1 mole, this is now the molar mass, for every 1 mole of iron, that is equivalent to how many grams of iron? Check in your periodic table. Iron is 56, round off to whole number, 56 grams. So that is iron is 56 grams iron. So you can cancel out the moles, then you will have the amount of the iron in grams. So therefore, compute it. So you will have 20 times 4 times 56 divide by 3. So that is this is 1,493. Point up to 2 decimal places grams of iron. So if you have 4 moles of oxygen gas, that's 20 moles of oxygen gas. So you need 1,493 grams of iron in order to completely react and produce 2 moles of ferric oxide or the rust. So the second problem, how many grams of rust are produced? So you can start with letter A, so you can start with 20 moles, or you can start with this one, the given, because you have already computed 1,493 grams of iron. You can start with that, or you can start with the original given. So to be sure that there will be no discrepancy, so we might as well start from what is given. So you are required here to solve for the rust. How many grams of the rust? So what is the rust here? That is the ferric oxide. So you can start from the given. So same step. So instead of iron, you will be solving for ferric oxide. So you can start with 20 moles of oxygen because that is the given, and convert this one to moles of the desired substance. The desired substance is ferric oxide. So what is the ratio between oxygen and ferric oxide? That is 3:2. So you can have here 2 moles of ferric oxide for every 3 moles of oxygen. So you can cancel it out. Then you can solve for the grams of ferric oxide using the molar mass. Okay, compute for the molar mass of ferric oxide. Okay, let us compute. So you have 2 moles of iron and 2 moles of iron and 3 moles of oxygen. So iron is 31, round off, 56, sorry, times 2. So 56 times 2, you will have 112. And oxygen, that is 16 times 3, so you have 48. So therefore, the molar mass of ferric oxide is 160. So you will have 160 grams of ferric oxide for every 1 mole of ferric oxide. So you can cancel out the moles. So therefore, that is equal to 160 times 2 times 20 divided by 3. So it will produce 2,133.33 grams of ferric oxide. Okay, so this is now the amount that is being produced. This is the amount of iron needed. So if you have 20 moles of oxygen, it needs 1,493 grams of iron to react completely in order to produce 2,133.33 grams of ferric oxide. We'll continue with the other problem with the next video, same reaction.